morning, everybody. President of Sibaka, Chairman of ACCI. I think this Udhaaharan is very unique, and I think it's a platform that kind of imparts practical knowledge to the entire diaspora, and I think it's very crucial that more events are held like this. And other dignitaries here. I see a lot of familiar faces from the industry. Welcome all of you. And if any students are there from the college, I welcome you as well. So just diving into my presentation, if you can just... So there are plenty of experts here who have already spoken a little bit, some experts after me. So I will try to dwell into some key points that I thought were relevant. So just mentioned it as changes and trends. So broad points that I thought I would touch are how the industry has been in the past and how it's in the present and probably looking into the future. Critical things that we see as floor loading. How critical is the floor underlay in the design of the floor? Joints, which are extremely crucial. Flatness and level floors, which play a huge part in the in some of warehousing operations. And typical flooring problems. I've just taught two. Obviously, there are plenty of problems that we face. How has warehousing been in India? I'm taking warehousing to be a typical case because warehousing is a part of the industry. So I'm taking warehousing because a lot of development has happened over there over the last 10 years at least. So this is how warehouses used to be. If all of you may remember, old warehouses, slow speed of construction, there used to be truss structures like this and mostly hand mixed concrete. So construction used to take, I remember my father, Sanmar group, Murugappa group, we've been working with 57. Ishwara was my father. He says he goes to N. Shankar, chairman of Sanmar. ஒரு பில்டிங் 30,000 ஸ்கொயர் ஃபீட் எவ்வளோ நாள் சார் கட்டி கொடுக்கணும்? ஒரு 6 மாதம் ஆகும் சார். பரவாயில்ல சார், 6 மாதம் 8 மாதம் ஆனாலும் பரவாயில்ல சார், மெதுவாக கட்டி கொடுங்க, அவசரம் ஒன்றும் கிடையாது, மழை வரதுக்கு முன்னாடி கட்டி கொடுத்துருங்க, ஸோ ஐ கேன் மூவ் மை எக்யூப்மெண்ட் இன்சைட். தட் இஸ் ஹவ் இட் யூஸ் டு பி. டுடே வி டாக் 30,000 ஸ்கொயர் ஃபீட் in about 2 months or 3 months time. So that's the difference that it has progressed in. And it used to be mostly designed for static loading and occasional loading using hand pallets. That's what it used to be. Maybe closer. So knowledge of flooring was fairly limited, and vacuum dewater floor is what is used to be the norm those days. So you pour concrete today, tomorrow you could walk on the floor. That is what it used to be. Now we were a little clueless as to how much cracking the floor used to be subject to do because of vacuum dewater flooring. So what is... skipping, So this is how warehousing has become today. Large span wire. So what are the features of warehousing now? You got large spans, effective insulation in walls, and very, very large floor plates. If you see this, you're having column with spacings of say 30 meters by 30 meters. And a typical PEB building like this. And what are the drivers of change? PEB has evolved from a normal steel building. It has become a feasible technical solution. Engineering has come in. Projects are getting completed in a much shorter span of time. We are talking about building 2 lakh square feet in about 10 months time. So that is how short, compressed timelines are. And a very, very professional approach to how PEB is handled. So I think it's about time we also professionally started approaching how flooring is being done. So what has happened now? So effective utilization of space. So this racking used to be a very, very common phenomenon in warehouse buildings about abroad. So you even go 20 years ago, you could see racking like this. This has happened in India only over the last 10 or 12 years. We want a trouble-free space. We don't want any sort of space with cluttering or problems or things like that. And last but not least, high-rise racking. This is actually one of our own projects. This is for a company called Reddington. I don't know how many of you have heard of it. So this was the first very narrow aisle, as it's called, was a project that was done for them. So high-rise racking, of course, this is the first project we did in, I think, 2004 or 5. Subsequently, we've handled high-rise racking of almost 20, 30 meters also. So that's, much later. So how critical has flooring become? So it has become so critical that the knowledge partners, ICI, actually commissioned a flooring guide. So it says guidelines on ground supported concrete slabs for industrial flooring and applications. So this bulletin was released in 2009. It was released, and several experts from academia, Dr. Ravindra Getu from IIT was part of that. We were part of that. We have contributed 2 chapters on sub-base preparation and on joints in this guideline. And the guide dwells on the entire range that a floor is subjected to, from floor loading, design, maintenance, pretty much the entire aspect. So what are the factors assisting high quality floors? Availability of high strength concrete with good quality aggregates, admixtures that assist in adding strength to concrete, availability of alternate options like the steel fibers, which have significantly reduced shrinkage of cracks, advanced machinery for flooring and components, proper joint plan with good quality joints. These are things that have aided high quality floor. And last but not least, with thanks to people like Yugal Flooring, we've got extremely good workmanship as well. I mean, they do fantastic work. So how is flooring in industry? What drives the flooring in industries? It is the most important part of the structure. I remember one client, I think somewhere in, was it Gujarat or Delhi? I don't remember. He says, sir, the building is a dead investment because it doesn't give any return to me. I want it to be as cheap as possible. But flooring, I don't mind you spending extra premium on it because it is something that has to last for 50 years. So when a building is a dead investment, but flooring is as important as, say, electrical system or a mechanical system, because without a flooring, he cannot manufacture. So that is how critical flooring has become. It carries more load, wear and tear than any other part of the warehouse. Generally, in many industries, floors are loaded far higher than what they were designed for. This is probably not in the case of warehouses, but in industry, it's very, very common. We have done plenty of industry, like say, for instance, say forging industry. We have designed flooring for say 5 tons per square meter, 10 tons per square meter, 300, 400 mm thick floor with double mat and everything. And then I go for an expansion 2 years later, I come back, there's a huge press that has come sitting right on top of the floor. I don't even know when it was brought in. It was not part of the original brief given. But he says, the floor is fantastic, sir. See, it's taking this load. That press weighs about 300 tons, but it's standing on that floor. So we, as designers, we have to take cognizance of all such variables that may come in even after we moved out of the project. Difficult repairs once manufacturing has commissioned. This is a typical project that we've done for Coca-Cola. Now you see, this is where your that fruit juice, a pulpy orange is made here. Now this is one line that has been put in here, and now subsequently another line has been added in this vacant space. Can you imagine repairing this floor if something happens? Impossible. You cannot get in. And secondly is the food industry, extremely hygienic. Nobody is allowed to even come in because dust is not allowed. And maintenance manager will hardly get time or permission from production to shut operation. I think one of the speakers earlier said the same thing. It has pressure of execution due to delays and other activities. So PEB is complete. The civil person, poor person, he's standing there. I need the flooring. I need you to start it tomorrow. So roof is not done. It's exposed to the elements. But do the flooring immediately because I need to start moving my machinery in. He is subjected to harassment. I myself as a consultant harass the contractor because he has to get the flooring. But I don't have a choice because client is harassing me. So we're all in the same vicious circle. We end up doing the floor and we hand it over. Eventually, if if everything goes well, all the parameters are good, then flooring is fantastic for its life cycle. Otherwise, we run into problems here and there. Always happens. So, what are the important aspects of flooring design? So, industrial floor needs to be designed as carefully as the load that it's going to take. Integrity of the layers below a ground supported slab is of vital importance to the long-term bearing capacity and the serviceability of the slab. For floors to perform successfully in the long term, the joints must be planned and constructed taking full account of the loads and actions to which they will be subjected. And last but not least, floor tolerances. So when you say floor loading, typical wheel load, say industrial floor will have forklifts. Wheel loading, type and method of operation of forklift within a warehouse is very important. The joints in particular take most damage due to forklift movement. So this is a critical loading. Rack weights. So like I said, we designed racks for 22 meters high and things like that. You get point loads in excess of 300-400 tons. So when you have to do that sort of flooring is a very, very critical aspect. And the problem with racks is they come with a very, very small base plate. They only come with say 600 by 800 or something like that. So there's a very, very heavy impact point load that comes on the floor. Future rank positioning, if possible, should be taken into account. Generally very, very difficult because we don't know how the industry is going to scale up. If possible, this would be extremely good parameter to have with us. Flooring underlay, all of you know this. Subgrade soil, long-term settlement of the slab is governed by the subgrade. There is potential for long-term settlements to be larger than elastic deflection calculated. So this concrete slab is designed for a certain amount of deflection. If we have not designed the subgrade properly, the plastic settlement of the subgrade could be more detrimental to the floor itself compared to the concrete topping. Poor subgrade could lead to differential settlements between loaded and non-loaded zones of the flooring. And soils with very, very low K value, which you can get using a CBR test, are indicative of plastic behavior and should be avoided. So low K value soils typically are avoided. You go to Gujarat and other areas, you get very, very black cotton clayey soils which are very, very poor. If you can avoid those kind of soils, it will be fantastic. Comes to subbase, which is the next layer. Main purpose is transmit load from the floor slab to the subgrade to provide a working platform for construction activity, provide a level surface for construction activity. This is extremely critical because if you have done the industry, the PEB supplier says, I need a level floor. Kindly give me a level floor in which I will get my boom crane or my tower crane, whatever it is, to come and erect the PEB structure. Very, very critical. I'm sure all of you are aware of it. Granular subbase is what we do. I'm sure most of you are conforming to the same standards. Last critical part is the joints. Concrete joints allow the concrete floor to move slightly, especially when subjected to wheel loads. Flatness of the floor. And the types of joints, isolation and expansion joints, construction joints, and contraction joints, basic three ones that we follow. This is expansion. This is a typical project in one of our sites that we have done. The purpose of expansion, obviously, the PEB column is fixed. And so the loads that are going to come on that column are very different from what the rest of the floor is subjected to. So isolating the flooring around that area and concreting it separately will allow for differential movement or differential loading to easily happen across floors. These are construction joints. They are the places where you stop the work. So you poured say 500, 600 square meters of concrete a day on the floor. You want to do the next of it next day. Then obviously you leave a construction joint like this with say typically using a metal form or a wooden form. And this is how the edge of a construction joint would be once you remove the formwork, so that the joints are all aligned. So you see all these plate dowels that are left in place. They're all aligned and they butt with the next construction very, very well. Control joints. Control joints relieve stresses caused by restrained contraction, drying, shrinkage, curling, and wrapping. So with proper depth spacing and timely installation, these joints will help control random cracking by allowing, if you see this, the crack has happened right below where the saw cut has happened. So it doesn't happen randomly in other places and your floor is still secure. There is no issue with the floor. Current challenges, flatness and levelness. So floor flatness for some industries, especially warehousing where you have high racking, is critical. 8 meters, I would say, is a normal industrial building where anybody today does about 25 feet, 30 feet is a very normal industrial floor. They have racks over there. So if you have 8-meter high racks for a 1.5 meter rack width, a 4 mm out at the bottom leaves about 21 mm out on the top rack. This is, industry will accept it because they typically use only forklifts, which should not be a problem. And rack aisle width is not critical. Whereas if the same thing, if you go to high racking systems, like you have ASRS, we have very narrow aisle equipment, they're very, very sensitive because they're all laser guided. So if you have the same 4 mm, the out alignment out here, it goes to 60 mm on top. That's literally 2 feet. So if you have a reach truck or if you have a VNA, the moment he's going, the rack will hit the VNA. He can't even load or unload from that place. So this is a definite no-no. 60 mm out is definitely not acceptable in any floor. So what do you do? Higher racking system with narrow aisle movement of equipment calls for stringent flatness and levelness nozzle movement. So what do you do? There are codes available for this. So we design for common international flooring called as FM. FM1 being the most stringent. So we have handled about 20 or 25 FM1 projects. Very, very critical, laid under extremely cautious conditions. We cordon off areas where we lay FM floors. I'm sure Yugal Flooring will be having an idea of it. This is the code to which we design. And it's fairly, it actually needs a lot of care to be, to do a floor as per FM1 standards. General problems encountered. I'm sure most of you would have seen this. Delamination. What is the reason for it? High water content. So in the batching plant, probably in the quality control, there is probably the water cement ratio, though there's something on the chart, what you actually get in RMC is a little different. Uneven distribution. So we all add floor hardness, like a dry shake powder that we add and we trowel it in. Assuming, say, that is not laid properly, you get these sorts of cracks. And the last but not least is the entrained air. So when you pour it, there's air inside, those bubbles kind of thing, they all group together and they spall. When they spall, you start having cracks like this. And this one is obviously, I'm sure all of you have seen this. This is the joint spalling. Primary reasons being improper finishing of the construction. So at the end of the day, if the joints have not been left out properly, you get joints issues like this, and improper filling of sealants. So yeah, so this is basically what I wanted to touch. Like I said, there are experts from this industry who are more. I'm not saying they are. We know a lot about floors, but I think but flooring is not our only business. So we do the building business is ours, whereas flooring is their only business. So obviously they possess a lot more knowledge, and I would now leave it to the panel to discuss more on the flooring here. That's all, and thank you very much for the opportunity. I hope we gain as much from this as that group has put together this event and bringing this forward. Thank you very much.